Okay, so this is a video on the pulley problem. So you can see that here's the pulley. It's going at a moving counterclockwise, and it has an angle of has an angle of omega. It's a small omega. And then it has a torque pulling it this way of 20 newtons, and then a torque pulling it this way of 40 newtons. So if you add that up, there's a sum of the torque pulling this way 20 newtons. I just didn't write that. Okay, so the question was asking for a graph of the angular velocity, and so it was actually C, and then this is what the graph looks like right there. So you can see that there was a high angular velocity, and then because of the torque, or because of the net torque pulling it 20 newtons this way, the angular velocity decreases, and then after it passes zero, it increases in the opposite direction. So this would start going clockwise rather than counterclockwise. And then using this graph, we can derive an acceleration time graph, and it would have a negative acceleration. And then we can also derive an angle time graph, so like theta. And so at first it would have a high theta, and then as it decreases in angular velocity, the theta would also decrease, and then as it speeds up in the opposite direction, the theta would increase drastically in the opposite direction. Since this counterclockwise is positive, once it starts going clockwise, then it would go negative. So that's what this is showing. This is showing the clockwise motion.